This is section 9.1 day 3, representation of functions by power series. One technique for finding a power series is to represent a given function is to recognize the function as the sum of a geometric power series. Today we use that technique. Example, find a power series for this, which looks just like a sub 1 over 1 minus r, centered at x equals 0. Find the first four non-zero terms in the general term. Also find the interval of convergence. So we're going to say that a sub 1 is 1 and r is x squared. The series is 1 plus x squared plus x to the fourth plus x to the sixth plus keep on going. So the general term is x to the 2n. Now if we wrote that as summation notation, sigma notation, it'd be n equals 0 to infinity of x to the 2n. So we have the first four. We got the general term, and now let's find the interval of convergence. Well, a geometric series converges as long as r is, or what we're multiplying by, is the absolute value has to be less than 1. Well, the only way we can get a value and square it and be less than 1 is if that number is between -1 and 1. So for example, if you have 0.2 and you square 0.2, you get a number less than 1. If you square 1.2, you get a number that's bigger than 1. So the math to actually do this is a little weird. You know, you have -1 less than x squared is less than 1, and you know, that's the definition of absolute value. But then I can talk about square rooting these two numbers, but you really can't square root a negative number. It would be imaginary. However, we're kind of square rooting each number in that, you know, the interval is -1 to 1 in order to have a value in which you square it, and that number is not bigger than 1. Well, the original number has to be less than 1. So the interval is -1 to 1. So the interval of convergence, -1 to 1 for x squared. Now, even if you had absolute value of x to the third is less than 1, now even though you could take the third root of -1, no problem. Even if you had x to the fourth is less than 1, that's -1 less than x less than 1. Find a power series for the next one. Centered at x equals 0. Find the first four non-zero terms in the general term. Also find the interval of convergence. So the first four let's do this. Let's go a sub 1 is 1. R is -x, because you can write this as 1 over 4 minus -x. It's got to be minus because the little formula for geometric series is a sub 1 over 1 minus r. That has to be negative. So the r is, did I say -1? No, -x. So the r is -x. First four non-zero, 1 minus x plus x squared minus x to the third plus keep on going. So the general term is -1 to the n if we start at 0, and then x to the n. The sigma notation would be n equals 0 to infinity of -1 to the n, x to the n. Now we're supposed to find the interval of convergence. So now the absolute value of -x has to be less than 1. So -1 less than x is less than 1. You know, it's not that we took the absolute value of this. Here, let me write it like this. We have -1 less than -x is less than 1. The negative doesn't really matter much. So we divide by -1. 1 is now greater than x is greater than -1. Well, if we kind of rearrange this, we get -1 is less than x is less than 1. So the interval of convergence is -1 to 1. Find a power series for this one centered at x equals 2. That's going to make it a bit of a challenge. Find the first four non-zero terms in the general term. Also find the interval of convergence. Let's write this as 12 over -1 plus 2x. I'd really like to get rid of that 2. So let's divide everything by 2. So this is the same as 6 over -1/2 plus x. Now I can center this at 2. We can write 6 over -1/2 plus x minus 2 and then plus 2. So if I minus 2 on the bottom and we plus 2 and we add 2, then we're really adding 0 to the denominator. Now when we simplify this, we get 4 halves plus negative 1 half is 3 halves. So 3 halves plus x minus 2. Now this is now centered at 2. But, we have some problems. This needs to be a 1. So let's multiply by 2/3. So multiply by 2/3, and we'll squeeze 1 in here. We'll multiply this by 2/3. 6 divided by 3 is 2. 2 squared is 4. 4 over. There we get 1. And then minus negative 2/3 x minus 2. Find the first 4 non-zero terms. Well, a sub 1 is 4. And what we're multiplying by is negative 2/3 times x minus 2. So the first term is 4. Then minus 4 times 2/3 times x minus 2. And then plus 4 times 4/9 times x minus 2 squared. And then minus 4 times 8 over 27 times x minus 2 to the third. Plus keep on going. Now the general term would be, let's go 4 times, it would be negative 2/3 x minus 2 to the n. So the sigma notation would be n equals 0 to infinity. And you could do this a couple ways. We could do 4 times negative 1 to the n, and then 2/3 x minus 2 to the n. So this is just the same thing, You could put the negative in there if you want. That's still negative 1 to the n right there. Or you could write it separately. Find the interval of convergence. So absolute value of, I'm not going to worry about the negative. So 2/3 x minus 2 less than 1, negative 1 less than 2/3, x minus 2 less than 1. So multiply by 3 halves. So negative 3 halves less than x minus 2 is less than 3 halves. And then add 2. In other words, add 4 halves. So we have 1 half less than x less than 7 halves. So the interval of convergence is 1 half to 7 halves. But, this isn't in the instructions, but let's do something else here. Let's find h of 2.1. And I'm using 2.1 because we're centering this at 2. And then we'll also we'll do the approximation to find p sub 3 of 2.1. And see if we're convinced that, we found the right series when we've done this correctly. So let's find the function value. Let's take 12 divided by 2 times 2.1 minus 1. So 3.75. So this is 3.75. Let's see what we get when we plug 2.1 in for this series. 4 minus 4 times 2/3 times 0.1. Because that's what you get when you take 2.1 minus 2. All right, and then we go plus 4 times 4/9 times 0.1 squared. And then minus 4 times 8. See, I got the 0.1 squared minus 4 times 8 divided by 27 times 0.1 to the third. And that's roughly 3.75. So I'm pretty convinced that we probably got that series right. So 3.75, 1159693. Students will be able to determine the convergence of a term and a series. Write the Maclaurin polynomial for sine of x. Well, that's an odd function. We have x minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial. Write the Maclaurin polynomial plus keep on going. That's going to be negative 1 to the n, x to the 2n, 2n. Well, if I start with 0, then I need that to be 1. So 2n plus 1 over 2n plus 1 factorial. Cosine is the even powers. We need 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus keep on going. Negative 1 to the n, if I start with 0, x to the 2n over 2n factorial. E to the x is 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial plus keep on going. So that's going to be plus x to the n over n factorial. This one's the power series. We got 1 plus x squared plus x to the 3rd plus keep on going plus x to the n. For f of x equals natural log of 1 minus x, let's look at natural log of 1 plus x, which is x minus x squared over 2 plus x to the 3rd over 3 minus, not plus, minus, x to the 4th over 4 plus x to the 5th over 5, and so on. Well, if we're going to write this as, let's write it like this. Let's write it as natural log of 1 plus a negative x. So it's like we took this function and plugged in negative x for x. So let's do the same thing for this. That becomes negative x. That squares the negative x and still stays negative. This becomes negative x to the 3rd. This stays as positive x when you plug it in, but then negative x, so all of these become negative. So we get negative x minus x squared over 2 minus x to the 3rd over 3 minus x to the 4th over 4 minus x to the 5th over 5. Keep on going. So the nth term is negative x to the n over n. But n's going to start with 1. So if we wrote the summation, if we wrote the sigma notation, we'd say n equals 1 to infinity of negative x to the n over n. For each problem, does a sub n converge? And then does the series converge? If it does, we're going to find the sum. So letter A, does a sub n converge? We have the limit as n approaches infinity of 2n plus 1 over n minus 3. That's equal to 2 over 1, which is 2. So does a sub n converge? Yes, it's converging to 2. B, does the series converge? The series diverges by the nth term test. Nth term test, because 2 does not equal 0. A, does the a sub n converge? We have the limit as n approaches infinity of 1/2 times 1 over 3 to the n. That's equal to 0. So, yes. Does the series converge? The absolute value of 1/3 is less than 1. So, yes. Yes, and then find its sum. The sum is a sub 1, which is 1/2 over 1 minus 1/3. Now that's 1/2 over 2/3. So 1/2 times 3/2 is 3/4. A, does a sub n converge? We have the limit as n approaches infinity of 4/3 to the n. Well, the top is winning the race to infinity, so no. B, does the series converge? The absolute value of 4/3 is greater than 1. Oh, and I wrote 0. Greater than 1, so no. That's a divergent geometric series. Find a power series to represent the given function and identify its interval of convergence. When writing the power series, include a formula for the nth term. Well, this is geometric, where a sub 1 is 1, and r is negative x plus 2. So the series is 1 minus x plus 2 plus x plus 2 squared minus x plus 2 to the 3rd plus, keep on going. Include a formula for the nth term. This is negative 1. If I start with 0, we're good, to the n, and then x plus 2 to the n. Well, now the interval of convergence is the absolute value of x plus 2. I'm not going to worry about the negative. Needs to be less than 1. So negative 1 less than x plus 2 less than 1. Subtract 2. Minus 3 is less than x less than negative 1. So the interval of convergence is negative 3 to negative 1. For the next one, we need this to be a 1. 1/3 over 1 minus 1/3 x. So a sub 1 is 1/3. R is 1/3 x. So the series is 1/3 plus 1/9 x plus 1/27 x squared plus 1 over 81 x to the third plus keep on going. So that's going to be, let's see, if I start with, this is x to the first. If I start with x to the 0, I would need x to the 0 over, no, I don't want to write that 0, I want to write n, but I'm starting n with 0. So x to the n over 3 to the n plus 1, because this is n to the 0 over 3 to the 1. The r is x over 3. We need absolute value of x over 3 is less than 1. So negative 1 is less than x over 3 is less than 1. So negative 3 less than x less than 3. The interval of convergence is negative 3 to 3. Turn into Google Classroom, determine if the terms converge, determine if the series converge, finds a sum if it converges. Do I have it all written out? The limit as n approaches infinity of 1 over 5n is 0. The terms converge to 0. And then the r, what we're multiplying by, is 1/5 is less than 1. That's true. We should probably have an absolute value there. And then here's the sum. 1 over 1 minus 1/5. That's 1 over 4/5. That's 5/4. So this converges by geometric series. 2a. Limit as n approaches infinity of 2n over 5n plus 1. That's going to 0 because the bottom is going to win the race to infinity. So the terms converge to 0, and then the series converges by geometric series. Probably should have absolute value there. And the sum ends up being 1/3. This is 1 over pi to the n. So the limit is 0. The terms converge to 0. A sub 1 is 1. And the absolute value of 1 over pi is less than 1. So the sum is pi over pi minus 1. This converges by geometric series.